In this problem, we are given in a basketball arena, 70% of the fans are rooting for the home team, 25% of the fans are wearing blue, 20% of the fans are wearing blue and are rooting for the away team, and of the fans rooting for the away team, 67% are wearing blue. So let's go ahead and we're told let A be the event that a fan is rooting for the away team. So let's find that in our information up here. What is the probability, or what is in the given information event A? Well, we're not really given an exact amount, but we are given 70% of the fans are rooting for the home team. So if 70% are rooting for the home team, well, that means that 30% are rooting for the away team. So what that tells us is that in our given information, we can gather from it fairly easy. 1 minus 70% is 30%. So the probability of A rooting for the away team equals 30%. Now, what else are we given? So we've got event A. Let B be the event that a fan is wearing blue. Now, that is directly given. 25% of the fans are wearing blue, so probability of B, probability of wearing blue, equals 25%. Then we're asked, are the events of rooting for the away team and wearing blue independent? So what else are we given in this information? 20% of fans are wearing blue and are rooting for the away team. So probability of A and B equals 20%. So let's look at independence. What do we know about independence? Well, we know that if two events are independent, we know that the probability of A and B, in this case, we're using A and B, just like in our formulas. So probability of rooting for the away team and wearing blue, we know that that's going to equal the probability of rooting for the away team times the probability of blue, probability of wearing blue. Those are going to be equal. But now we have probability in A and B is 20%. So does that equal probability of rooting for the away team is 30% times the probability of wearing blue, which is 25%, but that equals 0.25 times 3, that's going to equal 0.075. So that's not equal to 0.2, so we can definitively say no. The events are not independent. Now we could also use other probabilities that were given. Remember, conditional probability, the probability of B given A is going to equal the probability of B if they're independent. But it doesn't equal the probability of B because we're given in this, of the fans rooting for the away team, 67% are wearing blue. So probability of B given A equals 67%. That does not equal the probability of B, which is 25%. So we know that the events are not independent because of that as well. Now, what about mutual exclusivity? Are they mutually exclusive? Well, no, we're given the probability of A and B, the probability of rooting for the away team and wearing blue, equals 20% or 0.2, which does not equal 0. If it's mutually exclusive, the probability of them both occurring is going to be 0. So therefore, no, the events are not mutually exclusive or disjoint. Those are the same term, just different words, mutually exclusive or disjoint. So no, the events are not independent, and no, the events are not mutually exclusive or disjoint.